Okay, again, very quick video, because I have added, at least in principle, different driving modes, like PWM, that's what's used, but constant speed, and there might be constant torque, and even positioning, that's especially for robot, because a lot of people ask again, and here this nice guy added ROS2 control, and so he wanted a PID, and so I simply asked DeepSeek. You see, PID is something. Okay, here you can already enable one. Then please only remote dummy at first step, and only constant current power supply with maximum of 2 amps. And here, so you have 2.5 revs, so revolutions per seconds. You have to send multiplied with 1024, so you can send a small revs command. So that's the idea, because you always send integers. And you already in the remote UART bus, there is this config struct, and you can send the drive mode, so you can change the driving mode at runtime, from PWM to speed to torque later on. So that's here, and you have this nice new driver C file. That's the car driver. You see, the driver gets the input and is told how to drive the car. So driver. And here, that's a DeepSeek code. I don't really have any idea about PID. I'm a physicist, not an engineer. So you see, I always made a partial differential equation of 2 to integrate speed and acceleration, and that's how I, with a damping, to make my own control loop. But okay, PID. There is this driver simply called, and depending on the drive mode, you see either simply interpret the input as PWM and simply return it, or you call this nice PID update function. There is this an init with lots of these strange constants. I've tried to, but don't really. It's not yet. Okay, you will see shortly. And in the BLDC, you see there simply the driver is called with here with the input, and the override. I needed this because you see, if something's wrong with the motor and it's disabled, then the motor is always dropped, fall back to PWM, and then PWM reduced, and therefore this is this driving mode override. If you simply search here, you see then you see here, if the current is over the limit, or the BLDC is disabled or timeout, then the driving mode is set to 0, and the PWM that's the way, and here it's set back to. And I had to leave this low pass filter with rank 13 right now. If I usually I would set the PID control loop will not need a low pass. You see, the output should give them to the motor, but no, it was so it's still in place. You see here, I simply, if you really get a better code PID controller from Gemini or ChatGPT, or you're being an engineer, then you can try to override the filter. And the speed here is simply that's the position, and if the position changes, then I calculate the revs in a also multiplied with a shift of 12 and not 10, but somehow it works. I don't know. And if the speed is very low, then I also apply a very simple low pass of rank 2. And the idea is was if the speed is faster, then I better do the revs here X on a full 6-hole steps. That's how the speed is calculated when a full electrical revolution, that's 4 degrees times 6 whole steps, so 24 degrees. That's how the real speed is calculated. And so if the speed is very fast, it is better. And you also saw a nice, more smooth curve, but for some reason it doesn't work. So here this was the idea. If the speed is very fast, then really takes this revs that's calculated based on 6 whole step instead of 1. But that didn't work, and therefore I only now you see that's why here it's disabled, and that's why I added a filter when the speed is very low. So the filter is added when the speed is faster, but I couldn't for very low speeds. I really had to take the original. And okay, time to show you. There is in the beginning there is some here, and it's really okay. But here starts the STM viewer. Yeah, file has changed by now, and what's that? Okay, here we are. And to explain, you see the green is that what the PID loop is sending. That's the PV. It's the input filter, and this then gets this is low pass. And you see sometimes you see the green really going to the maximum of 1020. That's the limit of the PVM. So there's DeepSeek did not really get it perfect. What's more interesting here is the black. That's the speed really. That is, you see, and here at very low speed, I have to disable the low pass here now. Yeah, quite nice speed. And here that's again, don't know why, because here, that's what the PID should achieve, and it's always a bit too slow. You see, but you see if I here now push the more, it really, yeah, it's keeping the speed. You see, and this is totally different to the old PVM mode. So yeah, the constant speed is working for some reason. The PID loop, you see, that's really the black. That's the refs. That's the input. No, that's the value for the PID loop, and the blue, that's the input. So if you here go back to the PLDC, that's exactly what here the driver. That's the input. Is called with, and the driver then based here on speed mode is using the ref 32. So this is really the target value, but it's only below, and this changes if I play with these strange parameters. So you see, if I increase this here, then you get higher, and so no, the PID not really working. But I wanted to do the framework. You see that you no longer have to check with the BLDC. You only go to driver, and here you see that the PID, that's a DeepSeek. You can simply make a PID2 update and do your own PID here, and you don't need to worry about, you see that's the input, and no, that's the target, and that's the input, and that's the structure. That's quite, you see, you could make, you can I guess you can reuse the entire